I've decided to start a new space-themed video series. This will be the first part of many videos to come, and this video series is going to be all about the classification of stars, since this seems to be a topic that hasn't really been extensively covered anywhere. The early universe was nothing like the universe we know today. It was a mess of particles flying about chaotically in a hot, dense, plasma-like soup. As the universe cooled, hydrogen atoms would begin to clump together, forming large clouds of hydrogen and helium gas. And as these clouds began to collide with each other and heat up, they got denser and denser. And as the temperatures reached millions of degrees Kelvin, something interesting began to happen. The hydrogen would now begin to fuse into heavier elements, from helium all the way up to iron. These absolutely immense and dense masses of superheated gas form the stars that litter the night skies to this day. The remaining gases orbiting the young star would then begin to form solid matter, combining heavy elements from stars that previously went supernova with lighter gases from the parent star to form large boulders. These large boulders collided to form solid rocky planets, which might also have gaseous atmospheres. Most of the leftover light elements or gases from the parent star shifted further and further away from the parent star and began to form smaller balls of gas as gravity brought the particles together. And this is exactly how the gaseous planets that we now see on the fringes of our solar system were formed. And we can also see this happening across many other solar systems outside of our own. These planets formed quickly, only taking a few tens of millions of years to form, and are typically larger than rocky planets due to the fact that they are less dense and can therefore afford to be larger in size. However, there is one type of object that doesn't quite fit into either of these planetary categories. These objects aren't exactly stars either. At first glance, it would be mistaken for an incredibly large gas giant. But there is something off about these objects. It's almost as if they have a slight glow. As you peer closer into this planet, you realize that it's a lot denser than any gas planet you've ever seen before. It also appears to be a lot hotter than any other gas planet. This heat is fleeting, however, as these objects, unlike main sequence stars, cannot sustain nuclear fusion. They are failed stars, or brown dwarfs. Brown dwarfs were first hypothesized in 1963 by an American astronomer known as Shiv Kumar, who called them black dwarfs. They are no longer called this, as the name black dwarf is now designated to long dead white dwarfs, which we will get into in a later video. Every star is put into its own spectral class to determine its surface temperature. Brown dwarfs occupy the M, L, T, and Y spectral classes, with M being borderline red dwarfs at surface temperatures of 2000 Kelvin, and class Y brown dwarfs being under 300 Kelvin, which are borderline gas giants. These cooler brown dwarfs are just older brown dwarfs that have been around for longer and have therefore lost a lot more heat. Now, despite the fact that I said brown dwarfs aren't massive enough to kickstart fusion, they do sometimes fuse deuterium, a hydrogen isotope, in their cores. Both main sequence stars and brown dwarfs do this in their early years, but main sequence stars begin to contract and then fuse regular hydrogen, whilst brown dwarfs prevent further contraction with something called electron degeneracy pressure. In summary, in high densities, a gas composed of particles with angular momentum, or spin, is what creates this pressure, which prevents further collapse. These particles are called fermions, and as there can only be one fermion occupying a quantum mechanical state of a system, increasing densities force additional fermions to occupy higher and higher states of energy. This process is what increases the pressure of the fermion gas, also called degenerate pressure. Now, something you'll find about star type names is that they can be very misleading. Brown dwarfs are not actually brown in colour, at least not the hotter types. They are predicted to appear a very dark reddish to a magenta sort of colour instead. And as we get further along in our star classification series, you'll begin to notice a pattern of this sort of misnaming of star colours. Interesting things can happen within the atmosphere of a half-star, half-planet body, as you can imagine. Observation has shown that brown dwarfs may indeed have storms within their atmospheres, similar to the gas giants of our own solar systems. However, their storm clouds aren't exactly the rain clouds we experience here on Earth. On Earth, water evaporates and then condenses to fall back in its liquid state. On brown dwarfs, however, these clouds are made of iron and silicon, and yes, that means that it could potentially rain liquid metal on brown dwarfs, in the form of liquid iron and sand. And now, that's not a rainstorm you'd want to experience in person, that's for sure. Some brown dwarfs may actually have planets orbiting them, as plenty of brown dwarfs have been found with accretion disks around them, similar to the ones our solar systems were formed from. However, I wouldn't raise my hopes about any life on these planets, as the temperatures would be below 273 Kelvin or 0 degrees C, due to brown dwarfs cooling very rapidly and the window for life to form being incredibly tiny. However, whilst life may not form on the planets orbiting the brown dwarfs, something very bizarre and unexpected could be happening within the brown dwarfs themselves. Life. You may be asking yourself how this is possible if brown dwarfs don't have a surface, much like gas giants. Well, life doesn't necessarily need a solid surface to form. At just the right altitude, atmospheric pressures and conditions, it could be perfect for the formation of a very unique kind of life. You could have microscopic floating organisms like plankton carried around the star by winds and updrafts, and other creatures evolved and adapted to floating around in the upper atmospheres of these failed stars. This life would exist on the cooler brown dwarfs, of course, and it would most likely be nothing like any life form on a rocky planet. It could potentially be silicon-based, which would be inherently simpler than carbon-based life forms. The possibilities are truly endless. These life forms could also potentially withstand much higher levels of heat than we could, and they might possess shapes and sizes that we can't even fathom. Well then, that's the end of the first part of the series. The next video will move on to main sequence stars, so stay around for that. Once I'm finished with this series, I'll make a video on space-related viewer recommendations, and thanks for watching. And oh yeah, you better subscribe.